In this lesson, we will introduce concepts and tools revolving around team development. Let's begin by going over the major differences between proprietary and open source projects. Open source projects are available publicly. There is no management of developers directly as exists in corporations. Anyone can fork existing code and start their own derived project. To fork code means to take existing code and add to it. Proprietary objects are private and internal to a particular corporation. They involve rigorous project planning and management. Market share and competition are important to the corporation. There is also intellectual property protection. Open source licenses are used to govern how software can be used, modified, or distributed. There are two major types of open source licenses, which are permissive and copyleft licenses. Permissive licenses provide software as is, with no warranties. Permissive licenses allow for you to do whatever you want with the code, and use the code at your own risk. They generally acknowledge the author and contributors somewhere in the code repository. Some examples of permissive licenses include the Berkeley Software Distribution License, the MIT license, and the Apache 2 license. Copyleft licenses add extra requirements to the permissive license. For example, source code must be included in distributions of binaries. Source code must be available under the same terms under which you receive the code. Additional restrictions cannot be placed upon a licensee's exercise of the license. Some examples of copyleft licenses include the GNU Public License, or GPL, the Mozilla Public License, or MPL, and others listed here. Version control systems are used in software engineering to manage the code repositories for a project. They keep track of what changes have been made to a codebase, as well as who made those changes and when and why. This is very useful, even for an individual working on a project on their own, but it is especially useful for teams where multiple people could be making changes at the same time. While multiple version control systems have existed over time, without question, the system called Git is the most commonly used today. Git is a free, open-source tool that is installed locally on a system. Git repositories can be local to a single computer only, or it can also be synced up with an online repository so that the same code can be accessed more widely. Online repositories are also referred to as remote repositories. There are multiple cloud-based services that host remote Git repositories to allow teams to collaborate online using Git. The most popular include GitHub, GitLab, and Bitbucket. While they use Git, they are not the same as Git, but third-party services that are built on top of the Git technology. It's important to note that while Git is open source, that doesn't mean all Git repositories must also be open source. Git can be used in both open source and proprietary projects. Online repositories can be made private, requiring secured access. The commands listed here are some of the basic Git CLI commands. These can be entered directly into a terminal, such as Bash. To initialize an existing directory on your computer as a Git repository, while inside that directory, you would enter the command git init. You can also retrieve an existing remote repository via a URL and download it as a local repository using the command git clone, followed by the repository's URL. To add files to a local Git repository's staging area, you would use the command git add, followed by the file name. When you are ready to commit the staged files to a new commit snapshot, use the command git commit-m, followed by a descriptive message in quotes called the commit message. Aside from the CLI commands, there are many ways to interact with both local and remote Git repositories via interfaces. All cloud-based Git repository services implement their own GUIs, which can be web-based or desktop apps. For example, to create a remote repository in GitHub, you could log in to your GitHub account online and click the green New button next to the word Repositories on the upper left of your screen. Let's look at an overview of the life cycle for making contributions to a team project. First, a collaborator clones the central repository to get a fork of the code working on their own local system. Second, the collaborator develops contributions, then tests and commits the changes to their local repository. Third, the collaborator creates a new branch of the code. Fourth, they push the changes that they made to the online repository the code was forked from. Fifth, they send what's called a pull request to a maintainer of the project. Sixth, a maintainer will pull the contributions that were made and review them. And finally, the maintainer will either reject the contributions or approve and merge them into the remote repository. There are several tools used in the flow of team development. These include, but are not limited to, source code management and version control software for all size projects, for example Git. Bug and issue trackers that allow for easy management of bugs. Examples are Jira, GitHub, GitLab, and Bitbucket. Continuous integration tools are used to provide testing frameworks. Examples are GitHub Actions, BuildBot, and Jenkins. And mailing lists for announcements, discussions, and bug reports. GitHub and GitLab are two popular solutions that provide all these tools in a single platform. We will be discussing some of these tools in more detail in the rest of this course.